When we have a look at our original seed, thousands of years ago we had grass seed, and over time this plant is exposed to different climate conditions: heat, cold, droughts, rains, and the plants learn to adapt to all these different conditions. But essentially these conditions are all different magnetical and gravitational fields which the plants are exposed to, and they get to overcome those conditions. And what it's doing is it's adding layers of information to the seed's genetic makeup. And these are added year after year to the original seed so that it can cope with future conditions. And these layers of information which are added to the original seed will all be about germination, the size, producing different colors. So all these effects on the plants are all MaGrav fields, all fields of information which are added to the seed year after year. So this is nature, and then we come along and we add more changes because we saw this grass produced some seeds, so we cultivated them over time, taking only those plants that produced more and larger seeds and taking those and cultivating them further. And this is what we call wheat today. It's essentially a grass seed that has been cultivated and changed, and it's into what we know as the wheat today. And all these changes have been done over time by us and the environment. And it's just the layers and layers of different MaGrav fields which have been added to that original seed. We're still doing it today by naturally crossbreeding plants of the same species. A lot of growers will do that to try and get a bigger fruit, higher yielding plants. So it's all a crossbreeding which does happen naturally in the environment as well. The scientists have also stepped in and they started creating genetically modified seeds where they're forcing essentially cross-species engineering, mixing plant and insect and bacteria genes and DNA into the plant so that they can create plants that resist certain insects and pesticides. And it's just not a natural process, and I think that's why we're seeing such a huge backlash around the world against genetically modified seeds, because we just have no idea of the long-term effects of those. All right, so when we have a look at the seed, what I've tried to illustrate here is the green little oval circle in the middle was the original seed, and all those layers of information all MaGrav layers which have been added over time. So those layers of information would be about the color, the size of the plant. It helps it to grow in certain hot conditions, cold conditions. And when all these layers are added up over time, and you can get to essentially what we call the wheat today, which is the final MaGrav layer that's been added on, which is the red one. Now, what will happen when we soak these seeds in CO2? When you have a look at the CO2, it has a MaGrav field strength of 44. So you add up your carbon and your two oxygens and it gives you 44. Now, we've shown you earlier on that the water had a MaGrav field of 18. So now, if you're adding your CO2, your liquid plasma water, you're now exposing the seed to a MaGrav field of 44 instead of 18. So what this is going to do is start peeling away from the seed its different layers of MaGrav strength which have been added over time. So essentially by soaking the seeds in the CO2, we've removed certain layers of information from the original seed, until we reach a point where the last layer of information has a matching field with the CO2, and then at this point no further layers will be removed because a balance has been achieved. So the CO2 will allow us to remove certain layers of information that have been printed onto that seed until a point. We can look at soaking the seeds with CO2 and copper, or with zinc and CH3, and because we're adding higher strengths to that water, we will be able to remove additional layers of information until a new balance is created, and then no further MaGrav layers will be removed from that seed. So in summary, with the liquid plasma of the CO2 and other gases, we have the ability to restore seeds to their original. In other words, take all what has been added into information and MaGrav fields to that original seed, strip it all back and go back to that original seed. And the tests that have been done by Mr. Keshe have shown where they can take wheat and soaking the wheat in the CO2 water for certain lengths of time removes these fields of information, and the plant that they end up with is essentially going back to its original grass. So they managed to remove all those layers of information. But it does pose a couple of questions in that, do we want to go all the way back to the original grass? So when we start looking at stripping back these layers of information, it's what type of layers and to what extent do we want to go and remove these layers? Do we want to remove the GMO layering that's been added, the hybrid breeding, or even the 2,000 years of natural selection by farmers? You know, so we have to be careful on what we're wanting to achieve out of this. So by the same token, by removing certain layers of information from these seeds, we can also, I think eventually with science, understand that we can also enhance the seed. So we can go one way and we can also go the other way. So we can add certain MaGrav fields to our current seeds so that we can produce plants which have higher yields, more nutrition, are able to grow in more diverse conditions. So we can grow a lot more crops in desert areas, which we haven't been able to do before, or grow in very high rainfall areas. So we're able to add conditions and information to seeds for the benefit of us. This would allow current farming to be revolutionized in ways that we haven't even not been able to imagine yet. And by doing this, obviously we'll get to this point where we might not be able to want to eat food anymore, but I think there's a huge transition time where a lot of people will still need to eat food before we can go entirely onto the fields. And this will allow us to sort of feed humanity on a small amount of land, because if we're able to produce huge amounts of produce from smaller amounts of plants, smaller farming areas, so that we can feed the people, and then we can allow the rest of the farmers to become our new environmental regeneration specialists, so they can take their expertise and go and start regenerating nature, so that we don't have to use so much land for all our crops, and we can actually try and restore the land and put it back to nature. So it's an understanding of what we're wanting to achieve with the seeds, going back to the original or adding what would be for the benefit of everybody. And in that sense, we would like sort of your help at home there to do some testing. So take some of your seeds that you're growing with and soak them in your different GANS waters of CO2, copper, your zinc, CH3, soak for different times and plant these. And just take photographs and record their growth and have a look at the growth of other plants next to them, because they will also affect, if you understand, they'll also affect the plants next to them. It's not just a very isolated field effect. You will be changing the whole field around your plants. And give us feedback on these, because the more results we do on this, the more information we can gather. So we'd like, if you'd want to do that, and please let us know.